Well, hello, students. So I want to go over this material in class, but in case we don't have time in class, I wanted to do this type of research methods review. This will probably also be used for a bunch of other classes too. So if you're not in Psych 2010 and I gave you this to watch, that's totally fine. You might not even be at Salt Lake Community College. So, with that being said, this is basically a review of a bunch of the different research methods that we've talked about over the course of the semester. So, just as a reminder, and as we talk about other things within the course, to review like what are the research methods that we've discussed using, what are some critical things about each of these kinds of research methods. So basically a review of all the different research methods. This isn't an exhaustive list of every single research method that exists. It's pretty sparse on qualitative research methods, honestly. But we do cover the main ones that we've focused on through most of the course and some of the more common ones that exist. So let's jump into it. So starting with a couple qualitative ones, we've got a lot of different kinds of observations. So naturalistic observation is one that you can see an example here. This is probably not a great example of trying to stay completely out of the environment, because here they're interacting with a chimp. So with this though, you're trying to see natural behavior in the real world. So trying to observe what is happening, how behaviors work out between people, or in this case animals. So that's naturalistic observation. We talked about other kinds of observations as well. So laboratory kinds of setting observations, you might do a systematic observation. So in this kind of setting, you've got a lot more control over variables in a laboratory setting. So some examples that we might have used in class are for the strange situation, looking at the attachment between a child and their parents. So that is a laboratory setting, a systematic observation where generally you'll have some kind of coding scheme. You want to look for specific kinds of behaviors, versus here in a naturalistic observation, you're looking at everything, trying to record everything, and then after that you're trying to analyze how these behaviors are related to another, what could be happening. An example of this, of naturalistic observation, so scientists put cameras in a chimp's territory near their nests and things like that to watch their behavior in a way that was a lot less invasive. Obviously, their smell would still be around. There's these new devices around that they probably played with, things like that. But they're trying to do it in a way that doesn't change behavior for naturalistic observation. So from that, they observed some strange behaviors. They observed chimps. I think they were chimps. They might have been orangutans. I don't remember exactly the animal it was. But they observed a strange behavior that they hadn't noticed when they were in person with them. That every once in a while, some of them would come over and throw a rock at a tree and then go off with the rest of the group. Sometimes they would do this in a group, sometimes they would do it on their own. It was kind of an interesting phenomenon. And then from that observation, they tried to figure out, well, why are they doing this behavior? So some interesting studies, some ideas that they came up with. They thought maybe this was actually possibly a initiation of like worshiping that tree, so like of giving them life and coming back, kind of like a prayer to the tree. Could be something completely different. It's hard to know. So they're observing things in a more natural setting versus lab setting. You have here these people working on a computer or in a strange situation. You have a stranger come in, the parent leaves, the child interacts with the stranger, the parent comes back, both the stranger and the parent leave, and you're looking for those specific observations of how the child interacts. So you can do observations in a lab setting in a more systematic way, looking for specific behaviors. You get a lot more control over variables when you do that, which could be really useful depending on what you want to look at. Versus naturalistic observation, just in the world, what is happening. So with this, if you know you're being watched in any kind of observation, so even if it's a participant observation or it's like a classroom observation, the principal's in the back observing for like reviewing the teacher, people's behaviors will change or can possibly change. So that is something to be concerned about. So one that we've discussed quite a few times is survey methods. So from surveys, you can get descriptive research, you can get correlational research, you can use a survey in conjunction with like an experiment. So there's a lot of utility in a survey to use across a broad range of methods. You might even use a survey before you do a lab setting observation. So you've got a pre-test, you've got a lab setting observation, then maybe a post-test after or something like that. So a lot of these methods can be mixed together to see different variables in different ways. So with this, surveys in general ask people what they think, what they feel, how they intend to act in the future. So with this, multiple scales, like my survey at this point when I'm recording it, it might change in the future, but the scale of intended heroic behavior I've created is 8 questions long. So that is one scale, it's 8 questions. I can add that in a survey that's maybe 40 questions long, with surveys also of actual pro-social behavioral intentions or empathy or things like that, if I want to look at those variables in relation as well. So it's pretty quick and easy to do those kinds of surveys. 40 questions for an adult probably takes like about 12 minutes, maybe less. And it's pretty easy to do statistical analysis when you've got valid scales there and get a good amount of correlational research, do some of the more complicated modeling that we've talked about. So regression equations, looking at those to predict one variable from another, do factor analysis, see the structure of things, how they're related to each other, and maybe a path diagram, things like that. Interviews is another common research method that you might use also in conjunction with other research. So with an interview, you're often asking questions to an individual or to a group. With this, you can even do an interview survey. So your questions, you could literally ask a person a question. Actually, one way to build a survey is in one of the first steps of making a survey, you would go and ask the population, hey, read this question and then just tell me what you think about it. Like, what do you understand? What is this question asking? So you are interviewing them about your survey question to make sure that people actually understand, or people are getting from your question what you want them to be getting. So that's another example of these being used together. So while we're kind of separating them out and we're saying interview is this, survey is this, oftentimes you're doing many of these research methods together in one study or a series of study or a research program. So with this, with an interview, you oftentimes get more rich or deep data. So an interview of the course of someone's life, like them at age 40 talking about the most important parts of their lifespan. So maybe it's their marriage, maybe it's a very specific event, maybe it's getting a new job, a specific thing in their childhood that's really important to them. You're getting a lot more in depth with interviews generally than some of these other methods. So a standardized test is another one that we've mentioned a lot of times, maybe not focused on, but a standardized test can be similar to a survey. It can be different though too. So an IQ test like the Stanford Binet has you solving specific kinds of problems, trying to put things together. You could do a standardized test for how working memory works. So it's just something that's standardized. You can compare one person's score to another's. That's what standardized means. If you're in a stats class, that's the standardization. So it's standard. You can compare scores in a standard across other people. So that's what standardized tests are really useful for. So you've probably done, say, an SAT, an ACT, GRE are all examples of standardized tests as well. So you can use those in conjunction with, say, an experiment. If you want to know if your SAT prep course works, you do an SAT test before, do your prep test, do an SAT test after, see if your scores improved. So you're combining that standardized test with that pre-post experimental design. So case study, again, we talked hopefully a lot about this, that it's a super in-depth observation of some unique feature of a case. So this could be a person, one single individual, or one group that has something really unique specifically about them that you really want to study in depth. With that, in that case study, you might be doing standardized testing, you might be doing surveys, you might be doing interviews as well in this case study. So with that, a case is just a group or an individual that has something unique about it. So this child might have a really, really high IQ, so you study that individual because of that unique feature. This group of young people made their a club to do basically civic engagements, to do things around their town actively, like building a park and things like that, all run by children. Like, I don't think any of them in the group were over 14, so it was like kids in range from like 5 to 14, and they set this up all on their own. They worked together to do things in their community because they just wanted to do it. So it's a really interesting case, unique feature of this group, creating without any kind of like parent or oversight from an older person saying, hey, this is how to do it. So very different than, say, something like Girl Scouts, where there's kind of a structure already in place. They created this structure themselves, so that's a pretty unique feature. So it's a good example of a case. All right, so physiological measures. We've talked a lot about these. These are fairly popular now because pretty replicable, and a lot more people put a lot more weight behind them when you say you did an MRI study than say a survey study. It kind of has like to the layperson like, oh, that's going to give you lots of good data. There's kind of that understanding there. So fMRIs, hormone levels, stress levels, sweat, heart rate, all these kinds of things are examples of physiological measures that might be really relevant depending on what you're studying. So if you want to study meditation and mindfulness, you might want to know what's happening in the brain, or you might want to know if someone's heart rate actually decreases during that. So that's what we're talking about, physiological measures. So with this, we've talked about a bunch of different designs, and as I've been talking today, we've been talking about how a lot of times these can kind of combine and be used together. We've got descriptive research designs that's really focused on describing phenomenon, like what is happening here. Correlational research might be used in descriptive research, but with correlational, you're looking at variables, how they're related to one another. So you can do correlations in addition to experimental, in addition to descriptive, but we kind of put that in its own bubble too. So looking at relationships between variables for correlational. Then experimental, you've got control over variables, whether it's a quasi-experiment or a true experiment. You've got some control over variables, you've got separate groups to compare to one another so that you can get some more causal data. Now we'll talk about time span research designs like longitudinal designs as well. I probably should have put it on this group though. So descriptive research, you can do anything from observations to surveys, interviews, case studies, content analysis. So content analysis, I'm not sure if it comes up again in these slides here in the review, but that's basically looking at the content of maybe a book or a journal. So like someone's journal that they've written in to see, do they talk about this more, that kind of thing. So what is the content in this publication or film or documentary? So analyzing the content. So there's a lot of ways to do research that describes phenomena. With this, you're not trying to prove causation. You might have some ideas of maybe this causes this, but with descriptive research, you're not proving that. You might get some ideas though. Correlational research, again, focuses on correlations, so those relationships from -1 to +1, remember the closer to 1 it is, so 1.00 or -1.00, the stronger that relationship is. For some reason, I just was worried that I wasn't actually screen recording this, and I was doing this whole lecture. It is recording, so that's good. I guess that could be up and not actually be recording. It is recording. Okay, perfect. So the positive or negative tells us the direction of the relationship. So this is an example of a positive correlation. This is an example of a negative correlation. So the relationship is going this way versus the relationship is going this way. This is an example of no correlation. So this would be close to a positive or negative 0.000, versus this is going to be pretty close to probably positive 0.92 or something like that. I'm just making that number up based on like how straight that line would be. And then this one's probably a little broader, negative 0.64, let's say. It's probably higher than that, but let's say negative 0.64, just to give a sense of that. So how close it is to 1 tells us it's a stronger relationship. These two variables are more related to one another. So let's say this is ice cream and happiness, would make sense to be positively correlated. This is your scale of happiness. This is, and let's say, how many scoops of ice cream. So when you give someone 25 scoops of ice cream, they are as happy as they can possibly be, versus if they get 0 scoops of ice cream, they're not very happy. So this is a pretty strong relationship there. Something with a negative correlation, I think I might have some examples here of negative correlation. Oh, nope, I don't. So let's give an example of negative correlation again. So as one variable goes up, the other variable goes down. So let's say the number of people at a ski resort and temperature. So as the temperature is low, let's say this one is temperature, and this is number of people at the ski resort. So when it's very warm, let's say it's summer, you might have a few people hiking during the summer at the ski resort. When it's very, very cold and probably snow, you're going to have lots of visitors to the ski resort. So remember, negative versus positive is not a value judgment of like this is not a good relationship or this is a really great relationship. Negative versus positive is just mathematical, like a plus or minus sign in front of the statistic to show you which direction the relationship is going. So here we have a negative correlation between the temperature and the amount of people at the ski resort. So the temperature is this line. When the temperature is very low, let's say the temperature is 0, then there's lots of people there because there's lots of snow. When the temperature is, let's say, 100 degrees Fahrenheit, there's fewer people there because there's no snow at that time and there's just a couple people hiking. So there's a negative relationship there, a negative correlation, versus here we've got both variables going up at the same time. In these cases, there might be some causal relationship, but as a reminder, correlation does not mean causation. So key point, that'll be on basically any final that I bring this up in. Just a reminder, correlation is not causation. So those examples I might have given might have been. So here's some examples of actual data. So here is a heroism scale, a draft of the heroism scale, how it's correlated with a purpose scale, and how it's correlated with social heroism, which is actually a piece of this heroism scale. So we'd expect the heroism scale's 8 questions. 4 of those questions are on social heroism, so this relationship should be pretty strong between just those 4 questions and the whole construct itself. And it is. You can see this cluster is very tight, so people who scored low on social heroism also scored low on heroism in total. People who scored high on social heroism also scored high on heroism total. The correlation was positive 0.89, so that's the actual true number based on this graph. Then we can look at heroism and purpose. You see, it's not a really strong correlation here. It's 0.33. It is still positive, but it's not a very strong relationship. So here you can see there's a lot of variation around this line of best fit. So we do have some people who scored high on heroism and high on purpose, but we also have this person who scored pretty low on heroism and pretty high on purpose. This person scored in the middle on heroism and very high on purpose. And then here we have someone who scored low on both. You can see there's kind of a trend this way, but then we have this person who scored really high on heroism and really low on purpose. Right? So it's very spread out. So these are some actual examples of real correlations. So there is a relationship here. There is a slight positive correlation, but it's not super predictable. You can't really predict very well when this is your correlation, versus here you can predict pretty well because it follows this line really nicely. So that gets into regression equations. So here's some actual real data in some correlation scatter plots just to give you a sense. And this correlation is even weaker, but it's pretty close to this one. You can see it's a little more spread out. And that's this graph here is social heroism correlated to purpose, and its correlation is 0.29. So here's a couple other examples. Here we've got social desirability, which has 0 correlation, basically 0. So the closer it is to 0, basically means there's no relationship here. So it's very spread out data. No relationship to heroism. There's not a line positive or negative. The computer can find a pattern there, right? But really it's just totally random, which is good because you wouldn't want people who rank high on heroism to also be always ranking high on social desirability. You would want a really big range of that. You don't want it to be related to social desirability. All right, and social desirability is actually a little more related to purpose. Not so high that it's worrisome, but it's actually a little bit more related here. And then we can see, again, a real true correlation here versus no relationships over here. The strongest one is the 0.33, and that is purpose and heroism. So the same that we looked at right over here. All right, so let's move on to experimental research designs. We're not going to talk about every single possible one, but I'll mention a few. The big key here with experimental research is you can determine cause. So if you think variable A causes B, do an experiment. Make sure. So you need at least 2 variables. You can have lots more though, but at least 2, and you need to manipulate at least 1 variable. So you can manipulate more, but for the simplest experiment, you need 2 variables manipulating 1 of those, or you need to be looking at 2 variables manipulating 1 in order to determine if it's making a cause. So here we have our control group that is doing a test in an environment that is quiet, maybe normal school environment, versus here they have a band playing behind them. So that is the experimental group. We might have a hypothesis. Will the people with the loud music from a band, will they do worse or better on this test? So the variables we're looking at are noise level and test. So test score and noise level. Those are the two variables, and we are manipulating noise level and seeing if it changes test score. So we've got an IV, an independent variable. This is the one that the experimenter, or you as the experimenter, manipulates. So in this case, we have the sound level. So what kind of music is played, how loud the music is played. We are manipulating that variable. The dependent variable.
Wait, why?
Sorry, my child wants to play video games. So, dependent variable. So independent variable, that's the one the researcher manipulates. Dependent variable is the one that you're wondering if it gets changed. And now my child is chasing a cat around, trying to terrorize it because he can't play video games. So, dependent variable is the one that we're wondering if it changes. It's like your final measured variable. You want to see if it's changed based on your independent variable. So in our case, we've got the independent variable is the noise level. Like, what music, are you playing music? Are you not playing music? You might even have loud music versus soft music. That's your independent variable. And in this case, our dependent variable, the one that we wonder if it changes, is the dependent variable is the test score. So does it change their test score? Does the group with the music or without the music, who has the higher test score? So independent, dependent variable. Another thing to remember, you need at least two groups for a true experiment. So the best thing is random assignment or random selection into your control group, which is your manipulation group or your treatment group. So you send part of the people to your treatment group, part of your people to your control group. That randomization reduces, it doesn't completely eliminate the possibility that there will be something systematically different between the groups, but the more people you have, the more you randomize, so if you do good randomization, the less likely that there will be a result coming from something else other than your independent variable. So here we have an example. We've got orange people and purple people. Purple people is kind of hard to say, but it's also kind of fun to try and say. So we've got orange and purple people. Maybe being orange or being purple will affect how much the music affects you. So since that's a possibility, or it could possibly be a possibility, we might not even know. So we randomize them. We want to make sure we have equal numbers of purple people and orange people in each group. So we've now randomized them. We do a random number generator. This person gets a 1, they go over here. This person gets a 2, they go over here. This person gets a 1, they go over here. This person gets a 1, and then 2 and 2. So that's how you split them up. So in doing my research, often I have, like, say, surveys or interventions that people access online, and that makes it really easy. I can have a computer program just say, hey, the first person to get it, just randomly generate a number between 1 and 2. Based on that number, they get sent to a group or the other group. And so when you have a sample of, say, 400 or 4,000 or 4 million that have been randomly assigned, you're kind of randomly getting an assortment of people in each group. So let's say in your sample of 4,000, you have maybe 20% of that sample is a specific ethnicity. Let's just make it really easy. Let's say you've got 20% of your sample is black, and then 80% of your sample is white. If that ethnicity could possibly have a difference, well, then randomize them into two groups, and then you should have that same breakdown in each group. So if you randomize well, it should be about 20% black in group treatment group, should be about 20% black in the control group, and 80% white in both groups. So you want, and what about religion? You might not be asking people their religion. You might not be asking people their political ideology. You might not be asking people their age, right? But those things could possibly have an effect on your study. So you want to randomly assign them into groups so that hopefully in each group you have people that are representative of those different groups that you can compare to the people in the other group. So randomization, you could possibly, especially with a small sample like this, you've got 6 people here. If you randomly assign them, you could possibly, even with doing randomization, get all the purple people in the control group and all the orange people in the treatment group. So the bigger your group is, the easier it is to make sure that you're getting any potential difference. So we've been talking about demographic differences mostly, but what if attachment style has an effect on your study? So it's not the thing that you're studying, but maybe that variable affects how pro-social people are, right? So you might not be asking people what their attachment style is, but you want to split all those attachment styles, secure attachment style and insecure attachment styles, equally throughout your groups. Because you don't know, maybe it could affect. So when you do that, it limits the likelihood that that kind of variable will affect your design. Because you really want to know, just does the independent variable affect the dependent variable? Or do your 5 independent variables affect the dependent variables? So, but we won't get that complicated. With this, we can get a little more complicated with the strength of your manipulation. This, you would have maybe 3 groups. Level 1, you might have a complete control group, no weights. You're trying to see how it changes a dependent variable of weight loss or muscle mass or something like that. So that's your dependent variable, your final measured variable. Your independent variable is doing exercises. So some people do no exercises. Some people use 10-pound weights only. Some people use 20-pound weights. Maybe you have a 4th group. So you have no weights, doing no exercises, another group doing no weights and exercises, this group doing 10-pound weights and the exercises, and this group doing 20-pound weights and the exercises. Maybe through doing that you realize, oh, it doesn't matter if you use if you do the exercises with or without weights. Maybe just doing the exercises has the biggest impact, so it doesn't matter if you use weights or not. So that's a really good idea to do for making different strengths of manipulation. For our really simple example of the school groups having music and no music, the strength of manipulation is basically high versus low, or high versus non-existent. So, but you can have high, medium, and off. So maybe you've got a brass band that's really loud, maybe you play the recording a little less loud for a medium, and then not at all for off. You could have some kind of intense treatment. Maybe they're coming every single day for therapy, for example. Then maybe every 3 days for treatment, and then no days for the control group. Maybe you have a longer treatment. You do treatment for 5 months versus a shorter treatment for 1 month versus no treatment at all. So there's a lot of different ways to change the strength of your manipulation. So those are a couple examples. And that can help you get a little better knowledge of, well, is there a point where you could make the treatment stronger, but you don't need to anymore. So that's a good thing to do with that. So types of experiments, we've talked basically just about really simple ones. So post-test only, you've got your 2 groups. One gets a treatment and then both get a post-test. So there's no pre-test here. You're just comparing their scores in this group to the scores in this group. So hopefully you've randomized. Here you have a pre-test post-test group. So you get 2 groups. They both do a pre-test. Then you've got one that gets a treatment, and then you compare their post-test scores as well as how much change is between these. So here you can't get, with the post-test only, you can't get that level of how much did they actually change. You're kind of inferring they probably changed this much. But here you can actually see, okay, this group changed from a mean score of 3 to a mean score of 5 versus this group stayed at a mean score of 3. So that's something that you could do. So this is post-test only, this is pre-test, post-test. And again, we're not going to go through all types of experiments, but there's a lot more variations on this that you could add additional pre-test, post-test, longitudinal designs to this, case studies within there, adding on multiple types of studies within just the experiments. So quasi-experiments are a little different. So we've talked about these before, but when you can't randomly assign things to conditions or you can't actually manipulate something, you still might be able to do a quasi-experiment. So you're still trying to look at the independent variable's effect on the dependent variable, and you can still make causal inferences. It's generally just not as strong of evidence as a full true experiment. So some examples here. You might do a reversal design is one example of quasi-experiment. So this might be one single individual. So you're trying to see if some kind of treatment will affect a child's school performance. You want them to do better on tests, you want them to do better in school, so your treatment is to praise them. Maybe that's your treatment. So you monitor them for a week, see how many times they do their homework, for example. They never turn their homework in, they never do their homework. Then, starting the next week, you do a treatment. You start praising them for doing their homework. By the end of the week, they're turning in their homework most of the time. Then the next week, you take away that treatment. You stop praising them. They might keep doing it for a little while, but they might fall back to baseline. So these are kind of the patterns of results you might be expecting to see on a reversal design. And so this, you might not have enough people to do two groups. You might have one single individual or one single school with that you can't separate into different kinds of classes like a control group. So you don't have as much control over the variables here, but you have a little control. You can still withdraw the treatment, put it back. You could do this multiple times, see if the pattern matches what you expect it to be matching, that kind of thing. So you could do a multiple baseline design. So you could use multiple people. So that same treatment, you've got a whole classroom, you want to see if praise helps. Let's say, well here, let's ignore the variables here. Let's use school example. Let's say there's 3 students in your class that are biting other students, possibly, right? So they're biting other students. You want that behavior to stop. So some kind of treatment that you do, maybe you, let's just use the praise example again. You praise them when they are behaving well, see if their biting behavior stops. Or maybe you give them more attention or something like that. I'm not sure. Just any kind of treatment. So you've only got 3 people. So the first person, you monitor their baseline. At the same time, you're monitoring the other 2 people's baseline for a couple days. After those couple days, you start the treatment on the first person. And you see, oh, look, their behavior has changed. They're no longer biting. Then the next person, you wait another couple days, and then you start the treatment with them. You see, oh, that's the same pattern of results. Then the third person, they've gone about 9 days with their biting behavior. Then you start the treatment with them. And you see that. When you see this replicated across different people, gives you a little more surety that you have causal data there, that your treatment has changed this. So depending on what you're doing, it might be unethical to stop a treatment for a reversal design. So if you're giving someone a life-saving drug, you don't necessarily want to just take that away, right? It might make for a good reversal design, but it might make for a person who dies, and that's not what you want, right? So with that, the intervention's effect can also continue after the withdrawal. So if you did some kind of treatment that just fixed them forever, then doing a reversal design, you're not going to see this drop back to baseline, right? So something like this might be more useful. So this is the case when you can't always manipulate all the variables. That's why it's called quasi-experiment, because it's getting close to a true experiment, but you're not quite there. Another one that we've talked about is interrupted time series designs. This is one of the best examples of a quasi-experiment, or one of the examples where you can get the most causal data. So here we have measurement of garbage intake in tons for 2 different cities that are pretty similar size. So these 2 cities were really similar size. They were pretty close to each other, but not far enough away, or far enough away that you wouldn't be like driving from one to dump your garbage at the other. And they were about the same size. So here we've got the one with the dots here and the one with the lines here. So here's where the intervention started. So every day for months, so many days, over 50 days, you are measuring how much garbage is taken in. Then you start an intervention. This intervention specifically was on Mondays after the entire weekend. You didn't pick up any garbage. So there was such a big garbage problem. They're like, our landfills are filling up. Let's give people a sense of what that is like. So at the end of the weekend, we won't pick up garbage for an extra day. So we'll only pick it up Tuesday, Thursday, Friday, Saturday, or Tuesday, Thursday, Friday. So there's fewer days to collect garbage. People will smell that in their house. It'll be filling up their house. It'll help them see like, hey, you're making too much garbage, and then they'll decrease their garbage production. That was the hope. So they compared this group to this group, similar cities. This group did not get the intervention. This group did get the intervention. And you can see a difference in the graphs here. Soon after the intervention started, we see giant spikes in the data. This was basically every Tuesday, all the garbage that would have been put out on a normal Monday, plus the stuff on Tuesday, was all put out together. So this specific intervention didn't work. Later interventions did work. The garbage problems in these cities went down, so really good. But this specific intervention, we can see they collected tons of data, tons of, you could say, pre-test data, started an intervention, and here is the intervention, as well as, you could think of it also as post-test data, But you can't randomly assign people in these cities to move to other cities, right? You can't take people from this city and be like, hey, you're going to move to this city for my experiment. See, that's just not going to happen. But you can do an intervention of changing one of those variables. We're going to stop picking up garbage on Monday. And so you do that, see how it affects. You could do an interrupted time series design for a big government intervention for decreasing smoking. You could check an interrupted time series design, see if a specific law changed any kind of behavior. Did it change speeding behaviors? Did it change thefts in store behaviors? So interrupted time series designs are really good because you've got a lot of what you might consider pre-test data and a lot of post-test data. And here you've got a comparison as well with the interrupted time series. So you can get a lot of good causal data. It's pretty clear comparing these months to these months that something changed the behaviors here. So you've got a good causal data there. So let's move on to time span research designs, longitudinal designs, and cross-sectional designs. While these can be used in, say, experiments as well, so I've done experiments that are also longitudinal in their design. You can do cross-sectional designs too. These ones specifically are really good to learn about development over the lifespan. So for cross-sectional design, you would take like today, I would go out and say, get a group of 5-year-olds, 10-year-olds, 15-year-olds, and I would check maybe their memory capacity today. So that's a cross-sectional design. Today I'm getting just 3 separate samples, 5-year-olds, 10-year-olds, 15-year-olds, and I'm measuring them at the single point in time. I don't follow up with them later, and their data should give me some inferences. I should let me know, hey, do the 10-year-olds remember more than the 5-year-olds? The 15-year-olds remember more than the 10 and 5-year-olds? That will give me some suggestions that maybe memory capacity increases from those times. I don't actually think there is, if I remember right, any significant change between 10 and 15-year-olds, but just as an example, let's pretend there is. It's convenient because you only have to measure once. I can go today, I can send some lab partners to go to an elementary school, a middle school, a high school. Are 15-year-olds in middle school? I forget. With that, I can measure all today, and I can do my analysis, and I can get a paper on probably this is the developmental trajectory of memory capacity between 5, 10, and 15. So, but there is some limitations. These people were alive at different times. Maybe schooling changed completely in between the 10-year-olds and the 5-year-olds. So the 15 and 10-year-olds, they all went through, say, what was the one that was a few years ago? Some kind of education program, like a big curriculum change. No Child Left Behind? I think that's a long time ago now. But let's take that for example. So the 15-year-olds, the 10-year-olds, they all went through No Child Left Behind. The 5-year-olds did not. They went through a new education program. Maybe that makes the difference. Maybe the new education program is actually the bigger change in developing memory than the actual age of the participants. So that is a weakness for cross-sectional designs. So another one you could do is a longitudinal design. So with that, this is really great. It's kind of like the gold standard for developmental research. Is you take 5-year-olds today, measure their memory, then you come back and find those same 5-year-olds when they're 10, and you measure them again. And then you find those same 10-year-olds when they're 15. So you measure them over that entire time. So that takes, for your study, you now have to take that 10 years in between the first data collection when they're 5 and 15. So that's 10 years to get all of your data. That's a long time. It's going to take money. You're going to have to keep in track of these people. Some of them are going to move away. Some of them probably will die. Some of them will change phone numbers and you just won't be able to find them. So there are some weaknesses to longitudinal designs, making it hard to do, but you can actually track those individuals. Did their memory capacity increase from 5 to 10 to 15? So really neat. It's only through longitudinal research like this that we've seen that people's cognitive capacities, that's what this graph is here, people's cognitive capacities don't really start dropping off until they're well into their 80s. Before, it was considered that maybe even as early as the 60s, so your 60s, that your cognitive capacities would start to decrease. But there's even this drop here in the mid 70s is not really a very significant difference. So you can measure them, but as a person like experiencing life, you wouldn't really see any difference in your own capacities at that point. It's not till we get way over here, so into the 80s, that we see a consistent drop. But as well, we saw from these people doing these longitudinal studies following the same individuals that those people who did like cognitive training games or were more active in, say, with social interactions, were doing things that activated their mind more, reading more, playing cognitive games, learning new skills, learning photography, then learning how to ski, things like that, doing things that engage their minds, that their curve didn't just stay flat, that it could even increase, that their cognitive capacities could go up. And so I think that's a really promising thing, is you can improve your cognitive capacities even up until the day you die. And we wouldn't know that without longitudinal research. In the past, we did just cross-sectional research on these things. And so because of that, that's one of the reasons that we thought there was so much decline in even in the 60s or 70s to the 80s, is because the cross-sectional data seemed to suggest that. But again, it might have been because those older generations went through different schooling, didn't get as much cognitive training, so maybe their cognitive capacities already weren't quite up to what the younger generation was, who went through maybe better schooling, maybe had better access to training, better access to healthcare, things like that. So those kinds of things can impact a cross-sectional versus a longitudinal design. But again, longitudinal designs take a long time. This study, following people from when they were 25 to 88, that's a long time. You have to have that team of researchers keep track of these people for that entire time. So that's tough, but also amazing. So with this, you can combine these two. You can do what's called the sequential method and do half cross-sectional, half longitudinal. So if I say take 5 and 10-year-olds today, I do a cross-sectional sample today of 5 and 10-year-olds. I can measure them today. I can make some inferences. I can say, okay, so maybe between 5 and 10, memory capacity increases this much. Then I follow both those groups for another 5 years. So I'm doing both cross-sectional and longitudinal. So now the 5-year-olds are 10. Now the original 10-year-olds are 15. So now I have a whole track of data from 5 all the way to 15 from my cross-sectional sample. It takes less time, still get a broad span of data. It kind of gets rid of some of the problems with both, but it still has some of the problems of both as well. But this really can help, so that maybe today I can get a paper out from the 5 and 10-year-olds, and then in 5 years I can be like, hey, this is what it looks like in between 5 and 15. So it's pretty neat. So those are time span research designs. So here we've got cross-sectional, you've got different groups taken in one time. Longitudinal method, you take those people, you follow them over a long time. So longitudinal, long time, you follow them. Sequential, put them both together. Cross-sectional plus longitudinal. With this, a key point is, and I've kind of brought this up multiple times today, is that when we are doing a study, when we're investigating variables, when we're trying to understand, solve problems, or do just understand variables, we might use multiple methods in any given study. We might use interviews as well as surveys in an experiment. Or we might use multiple methods in a series of studies. So most of the papers that I've written and published have multiple studies, like study 1, 2, and 3, study 1, 2, 3, 4, 5, things like that. So I might do experiments where I use a pre and post test. I might also have a physiological measure of stress in that pre-test and post-test. I might have a survey with measuring stress as well as measuring maybe their demographic variables. Have they ever gone to therapy? Have they ever done mindfulness or something like that? So as an example. So I'm using experiment, I'm using a physiological measure, I'm using a survey measure. So that's multiple of these methods put together. Then I might follow them up 1 month later and do those same measures again. And then 3 months later. And now it's also a longitudinal study. I did an experiment and followed up longitudinally. So you can combine a lot of these methods. It depends on what kind of research question you're asking, what you should do, what would be the best to do, what do you have money to do as well. Basically do the best methods that you can afford to do. In some cases you might not be able to do a study that you really want to do because you can't afford it. So do some other study to get at those variables a different way that works well within your budget. So with this, use whatever methods, whatever measures, whatever combination is best to falsify your hypotheses, to understand and solve the problem, to have an understanding of how these variables work together. It might be for 10 years you're studying like a variation on these topics to get a really clear understanding. It's probably not going to be one specific study answers everything about one concept. So, and that is the point of research methods and how we go through the process of science. Again, I didn't touch on every single research method that we've even talked about in class, but these are the primary ones to remember and review and focus on. So hopefully you remember all of those and were reminded. Have some new examples today to add to your notes versus the examples that you had last time, or you can even think of examples for yourself. So I would suggest going through each of these types of research methods, basically each slide, and say, what is an example that I can come up with? That would be a really good way to review, say, before a final exam or something.